Hello again. Welcome to another video of the series SAP EWM meets automation, where we discover SAP EWM MFS in detail. My name is Hendrik, and today it's everything about identification. And we will be looking at the hardware and software perspective of identification points, or iPoints, as we call them in the area of SAP EWM MFS. So what's this video about? We will start with an overview about the process, so what actually happens at an iPoint. We have one example process flow. I took a practical example again to make it easier to get the bridge to the software part. Then based on this process, we will then look at the hardware at an iPoint, and in more detail, that is the longest part of the video, look at the EWM side, so the software part at the iPoint. So what happens in the back when some objects are identified, actually what happens in EWM. That's the main part of this video. As usual, as with all videos of this series where we discover EWM MFS, we had a close cooperation here with the EWM team at Swisslog, and the team is happy to help you with everything around SAP EWM MFS, so feel free to browse their website or get in touch with them via social networks like LinkedIn. As I said, we start with an overview of the process flow. I took a practical example, a very simple one. I mentioned it here already that we will be looking at a pallet, so a slow-moving environment. And I will come to the details, to the differences between pallet and case environments later in this video again. So between slow and fast-moving automation environments. So what is our example process about? We assume that we have an HU, so in this case a pallet, passing an iPoint. So we have a physical movement, a pallet moves via a conveyor, for instance, and passes an iPoint that could look like this here. And we will have additional examples for iPoints later in this video. So the HU passes the iPoint, and at this point in time, sensors are being activated. Usually we have some sensors which detect the HU as such and then activate other sensors, which, for instance, then read the dimensions, try to identify the HU, or capture the weight, capture the quality of the feeds of the pallets, the tunnel, for instance, and the runner, and all those signals end up in the memory of the PLC. So in the incoming signals are processed by the programs which are saved in the memory of the PLC. And based on this combination of incoming data and PLC logic, we have a telegram as an output. So a telegram, a string of data which contains all information that the PLC is supposed to share with EWM at this iPoint. So at this point in time, EWM has the information that was collected at the iPoint, and EWM processes this data, and as a reaction triggers a follow-up action that could, for instance, be an additional warehouse task which is responsible to move the HU away from the iPoint to its next destination. And this information again is captured as a telegram, and the telegram is shared with the PLC. The PLC again processes the information received via this telegram. PLC recognizes, okay, EWM wants to send the HU to the next communication point, and based on this sends data to other actors, motors, whatever. So the result of the processing this telegram could be the activation of the motor unit, moving the pallet via the conveyor to the next destination. And so as a result, we have a physical movement again. If you want to get more details about the telegram communication as such, I would recommend the video the video about the communication between EWM and the PLC. And if you want to get more information about the different objects which are used in the MFS environment, like what is a PLC, what is a telegram, all this stuff, I would recommend the introduction video of the interconnection between EWM and PLC. I will link both of them in the description and also here as an info card. Okay, so we covered the first part of this video. We covered the example process flow. Just keep it in mind. We will come back to this later. First of all, I want you to have a picture in mind about what we are talking about physically, and therefore I collected some pictures where we can see examples of eye points. So what do we have at an eye point usually is any kind of device which tries to read data from the object, from the HU which is passing by. That is usually a barcode scanner reading a label, a barcode or a matrix code or something like this. But that could also be an RFID scanner reading a tag or any other identification technology. Here we can see a scanner. Here, those blue guys. And in addition to this, we have sensors. We have sensors for the activation or the identification. Here you see some sensors. And here also. And we have sensors doing the profile checks, measuring the length, width and height of the pallet, usually installed in such a frame. And we have scales for weighing the HUs, usually within the conveyor elements. And we also have, in case of a pallet environment, usually have this tunnel or roller checks that you can see here. Yeah? Devices which will flap in case the pallet has any kind of damages or something between the feet. Okay, as I said, hardware is the shortest part. The core of this video is the EWM part of the story. So the processing of the telegrams for HUs which are identified at the eye point. That will be a deep dive with all the technical details. So after the next 15 minutes, you should be pretty familiar with the EWM part of eye point telegram processing. So coming back to our initial flowchart, we will be looking at this part here, the telegram which is sent from the PLC to EWM, how it is being processed within EWM. I tried to separate this processing of the telegram into 4 steps. First on a high level, and then we will go into detail. We start with the telegram, so the string of data received in the EWM inbound buffer, which is nothing more than a table, which stores the telegram data. And from there we proceed with the determination of MFS action, a so-called MFS action, which is nothing else than a function module which processes the data which is stored in the buffer table. So processes the telegram. That means that at first we need to determine this action function module, then we need to execute it. And at the end of this function module, we trigger the follow-up action. And that's basically happening within the function module, but I displayed it here as a separate step, so I thought it makes sense from a logical perspective that is a kind of a result, and it makes it easier to understand, let's say, put it like this. So usually that's the creation of a follow-up whereas task. As I said, I break down those steps into detail now for you, and then we will also look at the coding. Step number 1, as I said, the result is data in the buffer table, and it starts with this string of data received via ABAP push channel or TCP/IP converter like planned connectivity, and from there function module SEWM MFS receive 2 is being called, which is mainly responsible to write the data into the buffer table, but here you can also manipulate the data, for instance, via bodies and do some other stuff. That's not too important here right now. Just keep in mind, MFS receive 2 is receiving the data from the subsystem, enables manipulation of the data, and then finally writes it into the buffer table MFS SEWM MFS teleq. And once it is in, from here we call function module MFS process teleq to process this data. MFS receive 2 triggers this function module right away after it has written the data in the buffer table, but this function module here will also be called again later, for instance, via this periodic background job, which is trying to process the data from the buffer table periodically, because it must not necessarily be possible to process the data right away after it has been written in the table. So maybe there is no process available or some objects are locked, so maybe it can only be processed a couple of seconds or minutes later. And that's why we use this background job, which I also mentioned in the communication video, which I link in the description. And the call of this function module is the initiation of step 2, the determination of the MFS action. So what are we doing here when we're talking about determination of MFS action? The main purpose is to find a function module which should process the string of data that we saved in the inbound buffer table. And for this purpose, EWM reads the data from the buffer table, done by this function module, and in the second step, call function module MFS det action FM to determine the action function module based on standard customizing. And before we look into the customizing, I would like to show you a function group SEWM MFS underscore act, because that is an important function group in the context of MFS Telegram processing, as it holds all standard function modules for Telegram processing. So it's quite interesting to browse through these function modules. You can see a couple of ones for slow-moving environments, so pallet environments usually, and you can also see here the ones with this underscore case underscore for fast-moving or case conveyor environments. So if you just want to look at those Telegram processing function modules that the standard offers here, feel free to browse this function group. But how do we find the one that we use for our I-point processing here? That's pretty easy. Last look at the coding before we look at the customizing. This is the function module that I showed you before, det action FM, and here read single FM directly reads customizing tables SEWM TMFS act F. And from here we can find the action function module. And the customizing is pretty easy. You need these 2 nodes here. In the first one you basically define actions, just a 2 digits action identifier, and add an action function module. In this case it's not the standard function module, but rather the enhanced Swisslog version of the I-point processing Telegram. And then we have a determination table where we find the action that we defined here, which is linked to the function module, where we find this action based on communication point type, resource type, Telegram type. So in a simple setup like this, we have the Telegram type, which is stored in the inbound buffer table along with the Telegram data. And we could also use the communication point type, so that's taken from communication point customizing. and also resource type. So in case we are in a process step where a crane, for instance, is involved with a putaway or a stock removal task, we can also use this information for the determination of the action. So we find the action, we know which action function module is responsible to process the telegram. Good. Step number 3. We now process the MFS action. That means we execute the function module that we determined before. That means within the next handful of slides, we will focus on function module SAP EWM MFS act_sp. That's the function module which EWM standard offers to process telegram data at an I-point. The first step in this function module, 3.1, is to validate the HU. So does the HU actually exist in EWM? As said, we have a device there which reads data from the HU, reads the HU identification, and EWM checks, does this HU exist in EWM at all? Maybe there is a label on the pallet which has a number that is not an HU in EWM. If this is the case, EWM cannot move the object as such. You cannot create a warehouse task in HU warehouse task in EWM without an HU. So if it does not exist in EWM, EWM creates a dummy HU. Because we always want to be in sync between the physics and EWM. So, and we don't want the HU to be sitting there at the I-point forever. So in order to fix this situation, EWM creates a dummy HU. There's usually dummy packaging material assigned and a number range from which the HU number can be pulled. And then with this packaging material and this number range, a HU is created in EWM, and usually a follow-up task is created towards a clearing bin, for instance, and where the operators can check what's wrong with the label, for example. Second step is about adjusting the location of the HU. So physically the HU is at the I-point, but logically it might still be in the receiving area or at the in-feed communication point or somewhere else on the conveyor. So this function module, MFS HU adjust location, is responsible to post the HU to the I-point. And there are many different scenarios which are validated. EWM is evaluating the combination of HU data and warehouse task data in order to decide whether it's allowed to post the HU to this I-point or whether the HU needs to be rejected, for instance. And we also have a body here, just mentioned here on the slide, which can be used to manipulate this decision. So, for example, we could decide that we don't want to accept the HU at this I-point in case it is logically right now sitting in the high bay. That might be a situation where you have multiple physical HUs in your warehouse with the same HU number. If this is the case, let's say your supplier attached the same label onto physical two different HUs, two different pallets. And if you would now then post the HU logically, the HU which is sitting in the high bay, if you would post this logically to the I-point, that would mean that you create a bin in the high bay which is empty now, although it's physically filled. And you might want to include such checks within this body which is offered here. 3.3, next sub-step of this function module, is body SAP EWM MFS act_sp. And here we have three different methods which we can use, first of all, to change HU data. For example, based on the data that we collected at the I-point measured the height, and based on the result, you want to change the HU header data. You want to capture the height, or for example, change the HU type. And there is a method to execute additional checks. Any kind of validation that you want to include that is specific to your processes, your warehouse, your products, your objects, HUs, can also be included here, and based on this, you can set an error code which influences then the follow-up task. And last but not least, an important method here, a determine destination bin, where you can provide this fields here of the ls create HU structure, where you can already predetermine the destination of the task which is to be created at this I point. We come back to this later. At the end of the function module, standard will trigger the task creation, and either based on the data that you provided here or based on standard putaway strategy. Next step is the HU header attribute change. As I said before, based on the data determined at the I point, you might want to change HU data in EWM, like the HU type. And in order to execute this change, then we call the standard function module HU header attribute change here. Last step, still in this function module, but logically I highlighted it here as a separate step, as a trigger of the follow-up action, which means nothing else than the creation of the follow-up task. And this, as I said before, can be based on the destination that we determined in the body, or if we did not do anything in the body, we just read the whereas process type from the communication type, a communication point customizing here, and this whereas process type here is written from the customizing into the ls create HU structure, and based on this structure, then standard function module SCMTO create move HU. Here you see the table which shows the data from the structure above, and this will simply create an HU whereas task, and that will be the follow-up task here. And so either pre-given destination or whereas process type, and based on this whereas process type, just read the standard storage type search sequence and find a putaway bin based on the given strategy. That's it for our function module to process the telegram data. Just as a quick summary, does the HU exist? If yes, next step, if no, create a dummy HU. Second step, adjust the location of the HU, so make sure that the physics and the logic is in sync. Post the HU to the storage bin, which is assigned to the communication point, where the HU is sitting right now physically. Or decide that you want to reject it for any reason. Next step, call the body that I mentioned to change HU data or predetermine the destination bin for the next task. Then actually update the HU data, HU header attribute change function module, and as a last step, create a whereas task for the next movement of the HU. That's it for our standard function module for telegram processing at the I point. And to finally close this video, I would like to come back to the differentiation between palette and case environment. So that means the differentiation between slow and fast-moving environments. I would like to highlight here that I'm only touching the surface, because that's a topic that could fill at least one additional video. Maybe I will create one during the next months, but for now I would only like you to understand that there are differences due to the fact that cases usually need to move much faster, and there is not enough time to stop at the I point to make a decision about the next destination. And due to this fact, there are concepts like rough decisions. Like in order to enable fast routings, we have a slightly adjusted layout-oriented storage control concept. And we have rough bin determination, where we have temporary records for warehouse tasks and respective destinations in table SAP MFS HU move, which are then used to route the HUs, and we have planned routings in this context. So where we have routing of the activity area of the destination bin, of the rough destination bin, and also planned routing telegrams. And based on this planned routing telegrams, the PLC makes a decision at the I point. So we have an after-the-fact posting in EWM based on the decision of the PLC. And there's a fundamental difference to the pallet routing in the terms of like sequence of steps, but in general, the role of the I point is similar to the one in the pallet environment. And we have a different function module and we have different bodies, and we have slightly adjusted concepts here, but in general, the steps that I explained before, what actually happens at the I point and what are the different steps and what are the responsibilities of the subsystem and what are the ones of EWM and what is happening within the function module for telegram processing in general. That's similar between pallets and cases. So if you understood the concept here, you won't have issues to understand the differences that occur in a case environment. And as I said, maybe I will drop another video within the next months to highlight those differences. Having said that, we are done here for this video. As a quick summary, if you want to come back to those points, you might want to look at the blog where you have all the graphics and all the slides from this video, which show you this sample process flow, also the hardware, the examples that I showed you, and all the details of the software part with all the screenshots from the coding, all the objects in EWM. Feel free to take it from the blog. And having said that, I would be very grateful if you could subscribe to the channel. That motivates me to create additional videos. And as I said already at the beginning of the video, feel free to have a look at the Swisslog website, which shows you what the EWM team at Swisslog is doing and also shows you open positions at Swisslog in their EWM team. Swisslog is happy to have you on board, join their team as a MFS developer or consultant. And with this, I close for today. Hope to see you back in the next video and wish you happy learning.